Alrighty, YouTube. So we're in the middle of the 2022-23 SHSAT Handbook Review. We're on Form B. We're in question number 93, which is a probability and statistics question. There's about 4 more of those I'm going to do, plus there's other sections. I did some other sections already, so let's jump into it. Um, so and I categorize easy, medium, hard in different ways. Sometimes I might even categorize something hard just because a lot of students get a certain question wrong. Even though the concept may not be too deep, it could be the way the question's worded, a whole bunch of stuff like that. So always keep that in mind. Um, there's a bit of subjectiveness to this. I'm just basing it on what I feel, plus my experience working with so many students on so many of these questions already. Okay, so this is a word problem for sure. So let's be careful going through it. So a box contains an unknown number of green marbles. So let's call that X. So there's a box with X green. Okay, an experimenter adds 100 red marbles to the box. So there's now 100 red in the box. Okay. Let me make that an R so you guys an uppercase R. Mixes the marbles thoroughly, and then, so at this point we have the box, so there's 100 plus, whoops, that's not a plus sign, 100 plus X total. Okay, and on these kind of problems, no matter what form they are, I usually like this thing where I just list out each color, each shape, each whatever, and then write the total out. Just so my brain is used to that and it's just following. It's kind of like finding your givens, drawing out something, avoiding something, doing in your head. I don't want to overload my short-term memory, kind of stuff like that. And it's just the ritual. I'm trying to follow process, right? Process is really important on a lot of these questions. In any event, they draw out 10 marbles. So at some point, let me change the color of this. And maybe I should have changed the color, flipped red and green here, but we're going to remove 10 marbles. Okay, again, I'm just doing some bookkeeping to try to kind of make sense of it at random. All right, so there's a box with a bunch of green marbles. We don't know how many. Somebody adds 100 red, and they mix them together, and then they take out 10 at random. Assuming that this sample, what sample? The random 10, okay, is representative of the proportion in the box. All right, so that means because they mixed it thoroughly, basically whatever they pull out is going to be our experimental probability. It's an actual probability based on actually taking real marbles out of a real box. Okay, so if there are 2 red marbles and 8 green marbles in the sample, again, what sample? The 10 that were removed, right? Not the total box. Approximately how many green marbles are in the box. So this one just comes down to if 2 red, right, out of 10, which means versus 8 green then, right? Because 10 minus 2 gives 8. So out of the sample size, if 2 are red, then 8 are green. All right, that's really they're asking there. And that means for the representative sample, right, its experimental probability is basically 1 to 4 or 25%. Okay, you have a 25% chance of pulling a red out. That's what that's talking about there. In this sample, how many green marbles are in the box? Well, we don't know how many marbles are in the box. So how do we figure this out? What you need to do is realize there's a difference between the theoretical probability of something and the experimental probability of it. The experimental probability is the actual sample that you took out and pulled out, and you got 1 out of 4, right? That's what we got here, or the 25%. Okay. The theoretical is different. So that's why they're telling us And let me change the color here one more time. That's why they're asking us approximately, because there's no way to know for sure. We started out with an unknown number of marbles. We added 100 to it. That means we still have an unknown number of marbles. We just have more of them. All right? They originally told us there was unknown marbles, right? If we have unknown and we add 100 to it, we still end up with unknown prime, if you will. We still end up with an unknown number of marbles. Was there one and now there's 101? We don't know. Was there originally 100, now there's 200? We don't know. That's what makes this problem a little perplexing, even though the raw math is just basic, straight up arithmetic. Okay? So in any event, if our ratio is 1 out of 4, okay, they're asking us how many green marbles were probably in the box. That's where approximately comes from again. All right. So if the ratio here, the 1 out of 4, is red to green, right, and we know that we got 1 red to 4 greens, well, if there's 100 was added, then we're looking for this X down there. Okay. All right. And just let me change that because I used X for the unknown number of marbles earlier. Let's just call that, I kind of should have called the original one U. I don't want to use Y. What's a good number here? A. Okay. And at this point, we do the cross product, and we get A is equal to 400. Okay, and that's the answer. It's just plain old C. All right. And it makes sense when we think it through. If we were to plug in real numbers, right? If the number of green was the 400, right? We would get the 100 red, because originally there's only green in the box. So if we add 100 red and this 400 green, okay, that is 1/4 or 25%. Okay. Now, this is not asking us how many marbles are in the box. We do not know how many marbles are in the box. I talked about that earlier. There is approximately 400. Okay. Could there be 375 marbles in the box? Yep, there could be. That's not what the question is asking us. Could there be 430 marbles in the box? Yes, there could be. That's not what they're asking us. And by the way, I just said that wrong, because if it's 100 to 400, there's actually about 500 marbles in the box. I'm talking about the original greens, right? So I could just change what I just said there. If there's 475 or 525, yeah, it could still end up being about 400. It's still about 400. There's still about 25% based on the 2 red marbles out of the 8 green marbles. All right, so be careful with some of this. That's all they're asking you guys for there. My voice is going out again. I thought it would be good once I lost a bunch of students based on the previous exam. So that was 93. 98 is the next one. That's a little more involved. And by the way, that's part of your sanity check. Get the answer and rationalize it back out and see if it makes sense. And that's why 80, 300, and even D being 500. I can see enough people figuring out that there was 500 students, but if you feed that back into the question, that's not what they're asking you. Just take your time on some of these. Yes, you do have to pace yourself. Yes, you do need to keep moving. But if you just keep moving and only 80% answer every question, you're going to do worse than an 80% response rate on that. You're going to get most of those 80% wrong. All right, so be careful because you're answering different questions. All right, so what did I say, 98? Yeah, 98. Let's see. Okay, so this one's a good question. This one definitely, would normally get categorized as a hard, for sure. There's It's basically 2 levels. So let's just go through it. XYZ Corp hires 6 people as summer workers. So they hire 6 people. I'm just doing my bookkeeping over here. And by the way, I know I have space because I already answered that question. So you can use your space. We also at the bottom of this page here that they're giving us to do stuff with. Remember, sometimes that bottom can be deceptive. It doesn't mean you need to use the whole space. Really, in this case, it doesn't really come in handy. Okay. So of the 6 people, 3 will be hired as permanent employees. Which means 3 not permanent. In the fall. Okay, so we're done with those 2 sentences. If 2 of the 6 people are male, okay, so turns out we now have a second category of thingies going on here. So if we also look at the 6 people, and I can write that over here. Two are male, which means 4 are not male. Okay, this begs the traditional solution set here, but it turns out it doesn't quite help us too much. This looks like it's a 2-by-2 table. So if we would have set that up, okay, it appears that we have permanent versus not permanent, and male versus not male. Okay, and if we would have filled that out, okay, we know the total of each is going to be 6. Okay, so then it tells us there's whoops, I did that wrong. That would be 6. Let me get rid of that for a second. So it tells us there's 3 permanent and 3 not permanent. Okay, and then it also tells us that we have 2 males and 4 non-males, right? But the problem is, it says then when we finally get to the question, I'll underline that over here. How many of the possible groups of 3 hired in the fall will only include a male? This, we realize, wait, they're not giving us anything else here, so this is not the solution mechanism to solve this question. And this comes down to the old permutation combination kind of thingies. And that's what we should be using. So let me change the color one more time, just to be clear that we're not using the green as a solution set, or the blue for that matter. Let me use fuchsia. That's always a good color to use. All right, so what we have to do is basically take the sentence a few at a time. If so, they're going to hire 6, 3 will be hired as permanent employees. Okay, and they're asking how many of the possible groups of 3 that will be hired, right? These are only hirees. So we're not concerned about the non-hirees. We'll include only 1 male. All right, so basically what we have is a male followed by the other 2 hirees, right? 3 people are going to be hired. Yes? Okay. So how many possibilities do we have for this? They're telling us this too. Okay, and we almost have 2 problems we're trying to solve simultaneously. There's the 2 people are males, so that means we're looking at 6 minus the 2 males. We have 4 left over. That's what we wrote over here before. So now we have to work out of those 4 how many is left. So we have a possibility of 4 here and 3 there. So that's our traditional when we multiply that, and we get 12. However, uh, uh, person X and person Y is the same as person Y and person X. So if we divide that by 2, we get 6. All right? And that's the two things we need to combine now is this 2. Let me change the color one more time to show it on connecting. Let's use black. We're going to connect this 2 with that 6 through multiplication and get 12. Right? And that makes sense. So basically, we have male number 1, and then the other people, and then male number 2, and then the other people, and the other people is the same sets really, right? So that's why we have the 6. We can get the combo of the 6, and then just multiply it by each male, the 6 plus 6, if you will. So that's another way to look at this problem as well. All right, so this is a good question. I could see it being a lot confusing to a lot of students. Um, it, it's easy to avoid probability permutations and combinations under the probability and statistics realm. For sure, get all the other probability and statistics questions correct, though. This comes down to wording sometimes, and these usually take longer than the minute. So that's why you want to use your numeracy and all these other kind of things for a lot of the other questions, including the ELA section. Use your literacy and your things there to make sure that you have time to do the analysis of these questions. Right, 98 is a good brain slapper around her, and it's one of those things. And by the way, this kind of question kind of gets hard to double check, right? So you want to make sure you're familiar with this kind of thing. Run through enough of these to get them right. All right. So that's 98, and I think there's 2 more we're going to cover. There's 100, and this one isn't too bad, but I find it's in that whole realm of the probability stuff. But first of all, it's not really a topic you covered in depth in years past, and it's normally a topic that gets covered at the end of grade 7, early grade 8, or it might even be pushed back even further. And that even if your teachers took it or you're in an honors class or something, um, because there's so much content that the teacher needs to cover, it never quite gets its just deserves. So let's go through this and see what we end up with. Carl has 1 red spinner. Okay, so why don't we just do that with the colors? He has a red spinner, and that's normally a thing with an arrow thingy, and you kind of smack it with your finger, and it spins around. So they were telling us that each spinner has 4 equal sections. All right, so this has 1, 2, 3, 4, and then we have a blue spinner with the same kind of scenario set up. So again, draw it. Visualize what's going on. It's always helpful. Try not to overload your short-term memory. You're going to start overloading sensory stuff by drawing it, because you have to visualize it and see it, but so be it. I'd rather go with this. And as advanced as our brains are, they still mess us up, and intuition and a whole bunch of other things gets turned on end. So let's go through this again. Carl has 1 spinner, red spinner, 1 blue spinner. Each spinner is divided into 4 equal sections. Cool. Numbered 1 through 4. Totally awesome, bro. He spins each spinner once and writes down the number that each lands on. So this can land on 1, 2, 3, 4. And because it says he writes down the number that lands on, we're not running a scenario where the spinner is between 2 numbers. Okay? Same for the blue one. He can get either 1, 2, 3, or 4. All right, so we're up to here. So far, this is easy peasy. This is no brainer. This is ridiculous. This is like, bro, this is kindergarten. All right. So what is the probability that the 2 numbers, which 2 numbers one of the choices here times one of the choices here will have 4 as a product. So what we need to seek out is which numbers of those two choices equal 4. Well, 1 times 4 is 4, right? 4 times 1 is 4. And I put 1 there, I'm not sure why. And then 2 times 2 is equal to 4. And we also know that we can still get the 2 times 2 here, but you can't, because the 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 first two, let's assume this column here is the red, and the second column is the blues. We already did a red blue and a blue 2. We already did a red 2 and a blue 2, so we can't include that twice. So that's our 3 choices. Yes, 1 times 4 is the same as 4 times 1, but this is the red 1 times the blue 4, and the second one is the red 4 times the blue 1. So even though in terms of factor pairs it's the same factor pair, it's another choice given the context of what question 100 is asking us. So kind of all of a sudden we're in a little bit of helter-skelter here. Okay. So those are our choices. We only have 3 choices. We only have 3 choices. Out of how many possibilities? Well, there's 4 here and 4 here. 4 red and 4 blue. So we have 16 possibilities. We can list them out. There's 1 1, 1 2, 1 3, 1 4. 2 1, 2 2, 2 3, 2 4. 3 1, 3 2, 3 3, 3 4, and 4 1, 4 2, 4 3, 4 4. That's 16 possibilities. All right? So that's our answer. It's going to be 3 out of 16. All right? All right. And for those who made the mistake of including this, you'd have gotten 4 out of 16. And that's not a choice because they would have made it 1/4. All right. But they don't even give you that possibility. All right. It's not 1 out of 16. Logic that out. Use reason. Again, use your sanity check here. What is the probability that the two numbers from each respective spinner, when multiplied together, will have 4 as a product? Right? As a product, multiplication. This is not about addition. As a product, right? Have 4 as a product. There's only one that has 4 as a product. But that would be the 2 times the 2. But that's not what the question's about. That's not what the question's about. It's not which was the same on both spinners. We're randomly spinning each respective spinner. I may have just said what I just said a second ago erroneously, but I'm hoping the point comes across here. And that's the way to solve the number 100. And then we have 101, which is about the same question as this one here, but it can get a little more unwieldy. So let's give it a shot. I should have really spun off 100 and 101 by themselves as 2 distinct videos, but let's kind of go through this. So Melissa has a bag of marbles that are the same size. So there's not multiple bags. The marbles are the same size. Okay, so nothing seems important there yet, except that they're the same size. The bag contains 3 red marbles. Okay. 3 green marbles and 2 white marbles. So I'm going to build my normal table here. I get 8 total. And I'm going to double check that because I have dyslexia. And when I do stuff like this, in fact, I see words and stuff wrong too, but it's normally copying of numbers that kills me, even when the number started out as a word. So anyway, the bag contains 3 red, 3 green, and 2 white for an experiment. So here we're getting back to this theoretical probability versus experimental probability. And if you don't know what I'm talking about, Google it. Stop this video and Google it, or Google it afterwards, because this is important. It's important to know how to answer some of these questions by going through that kind of thing. So for an experiment, she would take 2 marbles out of the bag without looking. So she did the 8 minus 2. All right. So she's left with 6 marbles without looking. All right. Which list below shows the sample space for Melissa's experiments? Okay. Which would be that if she took 2 out? And again, sample space means it's working with her experiment. Just like the other question mentioned, sample space in context of those 10 marbles or 10 something that was taken out of another of that box or whatever with an unknown number of greens, the one we just did. So it's that same kind of thing there. So the sample space is like the answer choices show. It's actually showing 4 different scenarios of outputs that could be possible. So what we need to do is go through those choices. All right. So basically, if we were to list them out, we would get. Let's use the space here. Red, 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 green, and red, white. Okay. We're basically going to get 9 choices. We have 3 for the first one and 3 for the second one. So we multiply that out and get 9. Okay. So then we're going to have red, 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 green, red, white. We're going to have green, red, green, green, and green, white. And then we're going to have white, red, white, green, and white, white. Okay. And then we're going to notice that RG and GR are the same, so we can get rid of that. And RW here and WR are the same, we can get rid of that. And then GW and that, we're going to get rid of that. So we're left with 1, 2, 3, 4, 5, 6. So that's our pairs. So D would be the answer. And we can see from the choices that A makes no sense because there's only one of the marbles. There were marble pairs. 2 were taken out. So we have to list them that way. It's the first one and the second one. So that goes out. C goes out as well. And then we're left with B, which doesn't accommodate for the RR, the GG, and the WW choices, right? That's different than taking out the X's from over here that I did over here, all right? Because RR still is implying 2 marbles, right? That's why we removed A from the answer set here. So that's what they're looking for. The sample space is literally the actual writing out of all the possibilities. I generally don't like data solutions, but this is what they're asking us to do. So in this case, that is definitely the answer. Yeah, that's what we're doing there. All right, guys. Hopefully that helps. And the next time we're going to go through probably the proportions and rates and stuff like that as well. All right. Peace out. Please like, please subscribe. Hit me up at GregsTutoringNYC at gmail.com. Yeah.